Hello and welcome to this concise presentation on the Red Hat Certified System Administrator exam on Red Hat Enterprise Linux version 7. My name is Asghar Ghori. In this presentation, I'm going to show you how to accomplish various Red Hat CSA exam objectives on a live system. For this presentation, I presume you have enough working knowledge of Red Hat Enterprise Linux, CentOS Linux, Oracle Linux, Scientific Linux, or Fedora to comprehend what I'm going to demonstrate here, as I'm not going to talk about the basic Linux stuff. If you're new to Linux, I would advise you to study the essentials of Linux first in order to build the foundation. My focus today will be on performing tasks rather than discussing any associated theory. Please note that this is not a complete and comprehensive Red Hat CSA exam preparation presentation. I encourage you to go over my RHCSA and RHCSE exam preparation guide on RHEL version 7 chapter by chapter and practice the exercises and labs provided in that book to ensure success on the exam. Before I talk about the lab setup I have available for today's presentation and start doing stuff, I'd like to provide some essential information about the Red Hat CSA exam. All the Red Hat CSA exam information such as the exam code, cost, objectives, registration, duration, total and passing scores, etc. is located on Red Hat's website at the link that you see on the slide. The Red Hat CSA exam is 100% performance based, meaning that you actually have to perform the given tasks on a live machine. This implies that the more you practice, the better your chances are of scoring higher on the exam. The total number of tasks presented on the exam are more or less 18, plus a couple of mandatory tasks that you must complete. Points associated with each exam task are unknown. Red Hat has not made that information public. You must be well versed at the command line, able to modify configuration files using a text editor, and able to troubleshoot issues quickly if required. All information on the exam is provided in electronic format accessible from a browser window. I have a few suggestions for you to keep in mind before you begin your Red Hat CSA exam. Read the information provided thoroughly and carefully. It will contain critical information that will help you configure your system during the exam. Record your system's hostname, IP, and gateway. You will need this information to configure networking on your system. Note down the hostname and IP for the server hosting Yum repositories along with the protocol and directory location being used. Record the hostname and IP for the server running DNS, LDAP, NFS, and NTP services. These services may be running on more than one servers. All this information will help you solve many of the tasks on the exam. The exam tasks will be presented as a list of items with relevant detail appears when you click on an individual item. The exam tasks will not be listed in any logical order. I recommend that you read the description for all the tasks on the list and try to group them and accomplish them one group at a time. For instance, you may categorize tasks related to disk partitioning, LVM, file systems, and swap in one group, and tasks related to users and groups in another. This approach should help you identify the tasks that you might want to complete first before the others. An alternative approach would be to first perform the tasks that you think you can do quickly and easily, and then move on to the more complicated ones, keeping in mind any dependent items that must be completed prior to the others. During your Red Hat CSA exam, the only useful technical help available to you will be your access to the installed manual pages. You will have no access to the internet, no access to mobile devices, and no access to any written material. You will be allowed to reboot your system at any time and as many times as you want. However, you will have to ensure that your system comes back up clean and normal, and the changes you've made work without any additional modifications. The exam system will not have every required software pre-installed for you. You'll have to install any missing or required software yourself. The first thing the examiner does after your exam is over is that they reboot your system. The exam tasks are then graded and the results are emailed to you within 3 business days. I believe I've provided you with sufficient information about the Red Hat CSA exam. For more information, please visit this exams page on Red Hat's website. Now let's talk about the real stuff. For my presentation today, I have two virtual machines available with CentOS 7.0 preloaded. As you might know, CentOS is a clone of RHEL with a few minor changes, and it is available for free download. Both virtual machines are hosted on Oracle VirtualBox and are called station1.example.com with alias station1 and server1.example.com alias server1. I will use station1 to accomplish the tasks today. Station 1 is configured with one CPU, 1 gig memory, 8 gig operating system disk, and one unconfigured network interface, and it is running minimal operating system as the base operating environment. I also have a 2 gig disk on this system with a 200 megabyte ext4 file system in volume group VG10 pre-created. This file system is mounted on /mnt/lvol10 mount point with an empty file called testfile1 stored in it and an entry in the etc fstab file. Server 1 is configured with IP 192.168.0.200, netmasks 255.255.255.0, and gateway 192.168.0.1. To support some of the configuration items on Station 1, I've already set up the following network services on Server 1. An HTTP YUM repository for CentOS 7.0 software available at /var/www/html/CentOS, an FTP YUM repository at /var/ftp/pub/kernel storing a newer version of the Linux kernel, the network time protocol service, the Open LDAP service with a user account called LDAP user1 and TLS certificate station1 cert.pam, and private key station1 privkey.pam located in the etc open LDAP certs directory. NFS shared home directory /home/users/LDAP user1 for LDAP user1 account and the DNS service. Here's a list of mockup scenarios that I'm going to use for setting up Station 1. And as you'll notice, I have divided them in 6 groups based on priorities, similarities, and dependencies. One important point that I like to highlight here is that these sample scenarios are based on the Red Hat CSA exam objectives available on Red Hat's website and may have resemblance with the real Red Hat CSA exam questions. Some of these sample scenarios address multiple exam objectives. For instance, the first scenario in Group 1 covers 6 objectives. I strongly recommend that you do not restrict your study and practice to this short list of items. Expand your knowledge by learning the theory and extend your hands-on skill by doing the step-by-step exercises and do-it-yourself labs as I have provided in my RHCSA and RHCE exam preparation guide. Okay, so here's what each of the 6 groups include. Group 1 has 3 top priority tasks related to resetting the root user password, activating SE Linux in the enforcing mode, setting hostname for the system, and applying IP assignments to the unconfigured network interface. Group 2 includes questions related to configuring YUM repository and installing a newer kernel. There are 2 items in this group. Group 3 has 4 tasks and are related to user creation with custom criteria and group collaboration. Group 4 includes scenarios relevant to partition management. There are 3 items in this group on file system expansion, swap space creation, and a new file system setup. Group 5 contains 6 questions on scheduling a job with cron, creating a compressed archive, creating a link, setting ACLs, finding files, and searching for text. And the last group, which is group number 6, has 2 tasks to accomplish related to network time sync and remote authentication and auto mounting. Okay, let's get started with the configuration on Station 1 now. The first item on our list is to reset the root user password to CentOS, all in lowercase letters, in order to be able to log into the system. Here is what I'm going to do. I've already started the virtual machine by resetting it from VirtualBox console and have halted the auto boot process by pressing a key as you see on the screen. I'm now gonna press E on the selected default boot kernel in order to load grep2 configuration file contents. I'll scroll down to the line that begins with the text Linux 16 and use the right arrow key to move the cursor to the read-only option and replace it with read-write. I'll go to the end of this line and append enforcing equals 0 rd.break. I'll press Ctrl X to boot the system into emergency shell with SE Linux deactivated and root file system image mounted in read-write mode. In the emergency shell, I'll issue the change root command to make the root file system image, which is currently mounted on /sysroot, appear as mounted on /. I'll change the root password with the password command now. I'll issue the exit command to exit out of the change root shell. I'll issue the exit command again to boot the system to the default boot target. I'll now log into the system as the root user and restore SE Linux file context on the /etc/shadow file with the restore on command. This is the file that was modified when I issued the password command. The next item on our list is to set SE Linux to run in enforcing mode. To accomplish this, I'll open the SE Linux configuration file located in the etc systemscript directory. In the VI editor and change the SE Linux directive from permissive to enforcing. After making this change, I'll save the file, contents, and quit VI. The last item in group 1 is to set the hostname and apply IP assignments to the network interface. For setting the hostname, I'll open the /etc/hostname file in the VI editor and replace the existing entry with station1.example.com and save and quit the file. Next, I'll run the IP command to find the name of the network interface. As you can see, it is identified as ENP0S3. That's number 2 on the list. I'll now change into the /etc/sysconfig/network scripts directory and edit the ifcfg-enp0s3 configuration file for this interface. I'll change the boot protocol from DHCP to none. I'll add IPADDR directive with 192.168.0.100 IP address. Now let's move on to the second group. The first item in this group is to configure access to the yum repository that is available from server 1 for the operating system software. I'll change into the /etc/yum.repos.d directory and create file called centos.repo in the VI editor. I'll add a repo ID, CentOS repo, within square brackets, a description with the name directive, and values for the base URL, the enabled directive, and the GPG check directive. I'll save the file and quit VI after I'm done. I'll run yum clean all to flush the yum cache, and then I'm going to issue yum repo list command to load the updated repo configuration. And the output confirms the system's access to the repository. To test, I'm going to install bind-utils package from this repo. This package includes DNS client utilities. I'll run the yum command to install this package. As you can see on the screen, the installation went well and the package is successfully installed from the repo. The next item in group 2 is to install a newer version of the kernel which is located in the FTP repo on server 1. We first need to create access to this repo. And for this purpose, I'm going to cd into the etc yum.repos.d directory again and make a copy of the CentOS repo as kernel.repo file. And then I'm going to open up the kernel repo file and make modifications appropriately. I'm going to execute yum repo list to load the new repo configuration information. Now I'm going to execute yum install kernel to install the new kernel that is now available from the new repo. The installation will leave the existing kernel intact and automatically set the new kernel as the default boot kernel for subsequent restarts. I'm going to reboot the system now and let the auto boot process boot the new default kernel, which will be listed at the top in the grub menu. When the system is up, I'm going to log in and verify the new boot kernel with the uname command. And the uname command confirms the new kernel 3.10.0-123.1.2.el7.x8664. And this completes the implementation of both tasks for group 2. Group 3 has 4 user management tasks for us to achieve. The first item is to create a user called user10 with UID 10,000 and password user 10,000. I'll run the user_add command to create the user and then the password command to set the password for this user. For the next item, I'll run the group add command to create group user grp first. I'll then create user 20 and user 30 with the user add command with secondary group membership to the user GRP group. I'll now run the password command and set the passwords for both users to A, B, C, D, 1, 2, 3, 4. The third task in group 3 is to set up a directory for user 20 and user 30 for them to be able to share their files with each other. I'm going to go ahead and create a group called Linux ADM with the group add command first. Then I'm going to create a directory called /sdata. I'll change owning group to Linux ADM on this directory. I'll set RWX permissions for the group. And add set GID bit on this directory. Next, I'll add user 20 and user 30 to the Linux ADM group. To test, I'll switch into the user 20 account first and create a file under sdata. I'll exit out as user 20 and switch back in as user 30 and create a file under sdata. I'll run the ll command to observe the owning group for both files. As you can see, the file ownership belongs to the file creator. However, the owning group is common for both files, which will allow the two users to modify each other's files. The last item in group 3 is to create a user account called user40 with all the default user attributes. However, we do not want to give this user the ability to log into the system. In order to achieve this objective, I'm going to run the user add command and specify /admin/no login as the shell for this user. I'll now try switching as user 40 and see what happens. Sorry, I'm going to have to run it as the root user. This account is currently not available. We see an access this denial message on the screen for this user, which confirms the successful creation of this user account as desired. We have completed all 4 assignments for group 3. Now let's move on to performing the 3 assignments in group 4 which are related to partition management. The first item is to extend the ext4 file system currently mounted on /mnt/lvol10 mount point to 300 megabytes without damaging the data it contains. Okay, I'm going to run the df command to identify the device the file system is housed in. The output indicates that the logical volume is in VG10 volume group. I'll run the ll command on mnt lvol10 to check the existing data, and the output shows an empty file there, test file 1. I'm going to use the lvextend command to increase the size of the logical volume to 300. The current size is 200. lvextend minus uppercase L 300/dev/vg10/lvol10, extending logical volume lvol10 to 300 megabytes, successfully resized. I'll then run the resize to fs command to extend the file system the logical volume contains. The file system has been extended online to 300 megabytes, and we can verify this size, the new size, with the df command. So 293 megabytes. I'm now going to cd into the mnt lvol10 mount point and run the ls command to verify that the data is still there and intact. Okay, the second item in group 4 is to add a swap partition of size 350 megabytes to the system. I'm going to run the lsblk command first to check which device has enough free space available. Excuse me. The output shows that there is a lot of free space available on excuse me, on the SDB disk. I'll run fdisk on SDB disk and add a partition of size 350 megabytes with type 82 for swap. NP primary default 2 default start point 300 plus 350 M P to verify the new partition table. Now we're going to change the ID to 82. So type default 2 82 and P again to verify. SDB2 is the device file we just created, and Linux swap Solaris. I'm going to run the W command now to write the changes to the partition table on the disk and exit fdisk. Now we're going to run the partprobe command on SDB disk to update the kernel and create a device file for the new partition under /dev. I'm now going to create swap structures in the new partition, which is called SDB2, by running the mkswap command on it. Next, I'll make a copy of the fstab file. cd cp fstab.original. And then append the UUID for the new partition to the fstab file by running the blkid command and grabbing for the new partition device, which is SDB2, and pipe awk print $2, the second field. Okay, I'm going to append this UUID to the etc fstab file. Make sure that you use the double angle brackets to append. And now I'm going to open this file. In the VI editor, go to the bottom of the file. The UUID is already appended to the file. I'm going to add the mount point swap defaults 00. Save the file and quit VI. I'm now going to run swap on with the -A option to activate the new swap area we just added to the fstab file. I'm now going to run the swap on command again with the -lowercase s option to verify that a new swap partition has been added to the system. and the output indicates 358 megabyte swap partition. The next item on the list is to create VG20 of 500 megabytes with an extent size of 16 megabytes and containing LVOL20 logical volume of size 25 extents with ext3 file system structures and mounted on /MNT/LVOL20 mount point. For this exercise, I'm going to issue the lsblk command first to reconfirm the availability of enough free space on SDB disk. Okay, the first of the 6 assignments for group 5 is to configure a cron job for user 20 to run the ls command every week on Mondays and Thursdays at 6:30 p.m. and append the output to /root/lscron.out file. First, I'll edit the etc cron.allow file and add user 20 to the file to allow this user to be able to schedule cron jobs. Next, I'll run the cron tab command as the super user and open the cron tab file for user 20 and add the desired schedule in there. 30 minutes past 18 p.m. 1,4 corresponding to Mondays and Thursdays. The ls command, append the output to /root/lscron.out file. Save the file and quit the VI editor. The next task for us is to create a gzipped archive called etc_tar.gz in the root directory for /etc/sysconfig while ensuring that absolute path names are preserved. Excuse me. To accomplish this task, I'll issue the tar command with C to create, uppercase P to preserve absolute paths, Z to gzip the file, and F to specify the target file name, which is etc.tar.gz, and the source is /etc/sysconfig. I'll run the ll command. I see the file in there. I can also run tar tvzf on this file and view the files. Okay, the third task in group 5 is to create a soft link called test link for file /root/lscron.out. This file does not exist currently, so let's go ahead and create this file first. Touch lscron.out. Now I'm going to create the link using the ln command with the -lowercase s switch /root/lscron, and the target link is called test link in the tmp folder, and then run the ll command on tmp/test link, and there's a link created in there. The next item is to create file 1 under var tmp with ownership belonging to user 20 and owning group set to root user. We do not want user 10 to have any access on this file, but we do want this file readable and writable by user 30. To perform this task, I'll change into the /var/tmp directory and create this file, file1, using the touch command. I'll use the chown to change the ownership and group membership on this file. The ownership on this file to user 20. The owning group is already root. Next, I'll use the set facl command and on this file to set the desired ACL entries for user 10 and user 30. So set facl with the -lowercase m option, u:user 10:0, no permissions, comma u:user 30, comma 6, read and write permissions on file 1 for the 2 users. Next, I'm going to use the get facl command to verify the ACL entries on the file. The fifth item in group 5 is to search for only directories under /var/spool that are owned by the root user and copy them into /root/files directory. To perform this task, I'll first create a directory called files under root, mkdir files under root, and then run the find command to search and copy files in there. Find /var/spool, type D, only directories owned by the root user, and copy the directories recursively under the root files directory. Let's verify cd into the files directory, and we see several directories copied in there, and there are subdirectories and files copied as well. The last item for group 5 is to search for the pattern umask, all in lowercase letters, in the /etc/profile file and save the output to a file called pattern.txt under the root directory, while ensuring that the output file contains no empty lines. To perform this task, I'll use the grep command and grep for umask /etc/profile file and send the output to pattern.txt file in the root directory. After the execution of this command, use cat on pattern.txt to view the file contents. This completes all the 6 tasks for group 5. The first item in the last group is to sync time on station 1 with the time on NTP server 1. I'll first check whether NTP package is The first item in the last group is to sync time on station 1 with the time on NTP server 1. I'll first check whether NTP package is pre-installed. I'm going to use the yum command, yum list install pipe grep NTP. No, it's not there. I'll go ahead and install it with the yum command -y install NTP. Next, I'll open the NTP configuration file in the etc directory and add an entry for server 1 and comment the other existing server directives. I'm going to set the NTP service to auto start at subsequent reboots. Systemctl enable NTPD. And I'm going to start the service now. Systemctl start NTPD. NTPQ. I'll run the NTPQ command with the -p switch to confirm binding with server 1. This will probably take some time to bind with server 1, and you're going to see a little asterisk sign beside the IP address of server 1. Okay, and the last and the final item, hands-on item for this presentation, is to allow LDAP user 1 that is pre-configured on server 1 to be able to log on to station 1 with their home directory auto-mounted under /home/users. Okay, so there are 2 components in this scenario. The first one is to establish the auto mount service, and the next one is to configure OpenLDAP client access. Let's focus on the setup of the auto mount service first. We need to install the NFS utils and AutoFS packages first. So yum -y install NFS utils AutoFS. Now I'm going to create /home/users directory. I'll edit the auto.master file in the etc directory and add an indirect map entry for /home/users. Save the file and quit VI. I'll create and edit /etc/auto.users file and add the details for LDAP user 1 home directory to be mounted in read-write mode from server 1. Save the file and quit VI. I'll set the AutoFS and RPC bind services to auto start at future reboots. I'm going to start these services now. Okay, so the setup is complete for AutoFS. I'm going to run the ll command on /home/user/ldap user1, and the system should be able to auto mount the home directory for ldap user1 from server 1. So let's see if we see that. Okay. Now I'm going to run the df command to confirm the mount of ldap user1 home directory. And as you can see, the mount is shown in the output at the very bottom. Next, I'll configure the OpenLDAP client functionality. I'll install the OpenLDAP clients and SSD packages on station 1. Okay, installation of the required software is complete. I'm going to go ahead and run the auth config command now with several options. Enable LDAP -- enable LDAP authentication -- LDAP server equals LDAP : / server1.example.com enable LDAP TLS -- LDAP load CA cert equals FTP server1 pub certs station 1 cert.pam -- enable SSSD - LDAP base DN equals DC equals example.com DC equals com -- update. Okay, let's verify all the switches with the command. Okay, looks good. Let's press the enter key. Okay, the configuration appears correct. Okay, I'm going to use the get ent command now to verify the configuration. Get ent on the password LDAP user1. Okay, we see the entry. We see the entry that is read from server 1. At this point, both AutoFS and OpenLDAP client configurations are complete. I'll now try logging in as LDAP user1 using the su command and see whether it works. Great. As you can see, LDAP user1 is able to log in with home directory mounted automatically. Let's run the id command, the pwd command, and the df command to view the user ID, present working directory, and the mount status of LDAP user1 home directory. And as you can see, everything looks perfect. And that is the end of the hands-on part of the presentation. It is also the time for us to reboot station 1 and log back in and verify all the changes that we have made and ensure that all services and configuration are in place and working. This slide and the next 6 slides display the list of Red Hat CSA exam objectives. These slides show the objectives that we have covered or partially covered in red and those we have not in purple. For the objectives we have not discussed, please see the comments next to them. I strongly recommend to go over the theory and review and accomplish the exercises and labs provided in my RHCSA and RHCE version 7 training and exam preparation book, and not just rely on the hands-on assignments that we have done today. Thank you for your time for attending this presentation. I hope you would benefit from it. Take care.